All right, we're continuing our test 2 review. And we're supposed to write a balanced equation for the following. Yeah. You're gonna let me read it eventually? I don't know if you have it. Yeah, you have a blockage up there too. Okay then. See that way. Double displacement. Include phases, and phases are states. So this is where you're gonna have to use your solubility table again, isn't it? Aqueous potassium carbonate. You need your ions, everybody. Do not fight it. Potassium ion, please. It's in the first column of the periodic table. K plus. Carbonate. It's in your brain. There's not a lot of carbonate in your brain, by the way. It's in your bones more, but you have to store the formula for carbonate in your brain, and it's CO3 -2. You're going to use that. And aqueous aluminum nitrate. What's the aluminum ion every time? +3. Nitrate ion every time. NO3 negative, that's right. So when I'm doing 5, oh no, I hit the mouse. Don't hit the mouse. 5. I want the formula for potassium carbonate. Cross over the red ions that I listed first. And I'm not going to put crossovers because I'm going to use them to double crossovers, and it's double displacement. How many Ks and how many CO3s? I need the formula for potassium carbonate, everybody. And that's it. And how come I don't have a parenthesis for my polyatomic ion? There's only one of them. Carbonate solubility rules. Well, you don't need rules. Look, you're told. You don't have to do research when you're told something, right? AQ. Aluminum nitrate. I need its formula right now. Al, parenthesis, because you need 3 nitrates. NO3 is 1, and then you need 3. And it says that one's aqueous 2. Now you cross over to get K plus with the other anion. K plus with nitrate. Cross them over and tell me the formula when K plus meets NO3 minus. KNO3. Every nitrate is water soluble. How did I know that? Well, it's on the rule down here. Blow them up a little bit. Nitrates are all soluble without exception. So you're writing AQ, right? I got money. The last one's a precipitate, but do the work. Now, which one do you list first in the last formula? What element? The cation first, which would be the aluminum, right, is now mixing with the CO3 2-. I'll actually do that crossover right up here. Al3 plus CO3 2-, crossover in gray. 3 carbonates, 2 aluminums. Al2, oh, parentheses, CO3, 3 times. Rules on carbonates. Carbonates are insoluble. Aluminum's not on the list. You have to be on this list to be soluble. Everything else, insoluble. What do you write down beside it there? S. So you got to do all this work first. I want it to be very clear. You did everything here first before you attempted to balance the equation. How many times have I said that? That's at least 4. I'm going to go for 5 right now. So the only reason I'm copying this again is so you know he did not balance it until he got Everything else done first. I only need this final answer, okay? You don't have to copy it down twice. How do you want to start this balancing act? I like CO3 as a piece, because there's only one CO3 piece here. You see it? How many CO3 pieces over here? 3. How do you fix it? Where do you multiply by what? Put a 3 in front of K2 CO3. We'll put that in green. 3. Now your potassium situation just changed very drastically on the left, didn't it? How many potassiums do you have on the left side? K2CO3 taken 3 times. I mean, there's 3 of those molecules. Each molecule has 2. It's like you got 3 bicycles. How many wheels you got? Because each bike has 2. 6 wheels. 6 potassiums. How do you get 6 potassiums on the right side? Put a 6. Nice. Nitrate situation. Right side, 6. Left side, how do you get 6 out of a molecule that's got 3 already? How many molecules you need to get 6? Hey, I got a tricycle here. 3 wheels. How many tricycles do you need to get 6 wheels? And I believe it's done, because that gives you the 2 aluminums you need at the end, doesn't it? Yeah. There's a lot in this question, right? That's about a 5-point question right there. It's big. Okay. All right. And you know you're going to have a combustion. Balance the following combustion reaction. See notes, for example. I got. I'm just going to put it in the question. Balanced combustion reaction. We done. Yeah, we did octane. We did propane. We do methane. Methane, and you got you don't have to know its formula. I have to tell you its formula. CH4. In fact, I don't even want to use the parentheses. I say equals CH4. So I want to do a combustion reaction, question 6, for the burning of methane, and I'm only told its formula. Oh no. You got to provide everything else. What's the other reactants, please? O2. Reacts to give. 2 products, please. Yes. Carbon dioxide and H2O. It doesn't say you need states, right? So I don't bother. I don't need states if I don't ask for states or phases. I prefer the word states. So what are you going to get? Let's see. You want to do the carbons first? They're done. There's 1 carbon on each side, right? Move on to H's. Don't move on to O's. O's are last in a combustion reaction. They appear in 3 locations. So you're going to say H's. How do you fix the H? What do you put? Where do you put it? Multiply the second H by 2. There you go. Yeah. Did that finish it? Not quite. We're close. You got to do an oxygen count now. You're committed to the 1 in front of the CO2 and the 2 in front of the water. So you get 2 O's from CO2. You get 2 O's from 2 waters. That's 4 O's. How do you get 4 O's on the left side? Place the 2 in front of O2 and you're done. We like it. Write a balanced acid-base reaction. I'll come up with one right here. Let's do sulfuric acid. And potassium hydroxide. Okay, so that's our question 7. Sulfuric acid. Oh, it's an ic acid without a hydro in front. Atikitis. 8 ions gave ic acid. So, sulfate. What's the formula for sulfate? Sulfuric acid has sulfate in it. Oh, nice. With stereo. SO4, 2 negative. So that's going to go with H plus, comma, and crossover says, how many H's, how many sulfates? 2 H's, 1 sulfate. Acid-base reaction doesn't ask for states. That's good. Potassium hydroxide. K plus, OH negative, right? 1 to 1. KOH. It's an example of a double replacement again, ladies and gentlemen. So H plus is going to end up with OH minus now. You can write it down as HOH if you want. So please remember, HOH is called water. That's water, isn't it? Cation H, anion OH. Put them together. Cation K plus, anion SO4 2 minus. What's the formula? Cation K plus, anion SO4 2 minus. What's the balanced formula? K2 SO4. And I'm going to copy paste and balance. Just so you know, you do everything else before balancing. Do not try to balance in the middle, guys. It will never work out for you. Chemistry will be a nightmare if you're doing balancing before the end. Don't try to be the one that finds the trick. There isn't one. Okay? All right, so I'm just trying to help. Balance last. How do you balance one of these acid bases? The K situation looks good. H's are everywhere, right? Don't start with H's. They're everywhere. But K is only in 2 locations. I like that. How do you fix the first K? Multiply by 2 and KOH? Yep. Now you do remember that every time an H plus meets an OH minus, you get a water. Every time H plus meets OH minus, you get a water. How many K plus, how many OH minuses are there? Is what I wanted to say. 2 OH minuses. How many H pluses? 2 H pluses. How many waters? Every time H plus meets OH minus, you get a water. How many waters are made in this reaction? 2. 2 OHs met 2 H pluses. Each time they met, they made a water. Okay? And there's your final answer. And balance reaction between an acid and a carbonate. Okay, I got to give you an example for that. We'll do hydrofluoric acid and sodium carbonate. Hydrofluoric acid and sodium carbonate. Say. So hydro is binary. That means there's H plus and only one other element. What is that other element? F. And of course, it's got to be an element that balances H plus. So it's really an ion, right? 8. H plus and fluoride, which is F minus. And it was, did I say sodium carbonate? I can't read my question anymore. Okay, sodium is Na plus, carbonate CO3 negative 2. Good. So you can come up with the formulas now. H plus, F minus, they mix once each. Crossover says you need 2 NAs for 1 CO3. When you get the products, you just flip-flop the ions, always cation first. So H plus is now going to meet up with CO3 2 negative. Cross them over. H2CO3. And there's something special about H2CO3. I'm gonna throw a little curveball at the end here. This is only good for the carbonate reactions, okay? H2CO3 doesn't stay like that. But the other one is you did the H plus with a CO3 2 minus. I need the Na plus with the F minus. What do you got? NaF. And we have a review here. Review. H2CO3 decomposes to, if I told you it gives bubbles, you've seen these bubbles. Then that's a gas, right? You got it. CO2 gas. And tell me what's left of the formula when you remove CO2 gas from H2CO3. H2O. So how are you going to memorize that? Say, oh, if I make H2CO3, I'm going to replace H2CO3 with those things. So your real right answer, HF plus Na2CO3. This is before you even about CO3, Dr. Whitaker. Wow. That was weird. C and S sulfate. Start with an S sound. Try to understand brain breaks. Don't write H2CO3. Write the red thing. CO2. It doesn't say you need state, so I'm not going to write gas. I wasn't asked for them. Plus H2O plus NaF. There you go. Carbonates do that. If you get H2CO3 ever, it busts down. So now balance. I would start with the old sodiums. H is okay. You could start with H. Which one do you want to start with? H? Let's start with H. It's only here and here, so it's okay to start with H. I got 2 H's here. How do I get 2 H's here? Put a 2 in front of the HF. Correct. And F's are now messed up, right? How do you fix the F on the right side? Place 2 in front of NaF. NAs just fixed themselves, didn't they? Oh, I love this. Carbon, there was never an issue with carbon. 1 and 1. You want to just count oxygens and see if we're finished? Because I think we are. I got 3 oxygens on the right, 2 in CO2, 1 in water. I got 3 oxygens on the left, all of them right there. So I only need this last thing copied. And that will be the end of this video.